Welcome, everybody, to Dick's Dorks and Destinies. I'm your host, Chapel, and today I'm here with Crash and the Kid, and we're talking about Flat Earth.
And today's episode is brought to you and sponsored by Equal Opportunity Insurance, where your privacy is our policy. But yes, today's episode is Flat Earth.
Yeah.
So,
All right.
before we get fully invested into this episode, where does everyone stand?
Um, I don't necessarily 100% believe it, but I can see some of their points. Not all of their points. Their model definitely has a lot of problems with it. Um, but the idea that maybe the Earth is a lot bigger than what we've been led to believe is possible.
What about you, Crash?
So you're saying it could be an octagon?
Okay, so Crash is like, I don't give a fuck. I don't believe that the Earth is flat. I can't see it. I can't visualize it. I can't do anything with it.
Yeah,
I
no,
find a lot of flat earthers arguments completely stupid. And the biggest reason for that is, how does flat earth explain lunar and solar eclipses?
yeah. Yeah, they even admit their model has a lot of problems. The thing is like, so I have looked into it. Um, from what I understand, the only pictures we actually have of the Earth are composites of other things. They've never like sent a satellite up and taken a picture of the full Earth and sent that back, to my knowledge.
I can agree with that. That they haven't done anything like that to disprove flat Earth, but science has disproven flat Earth. People have set up countless cameras at night and watched the skies and recorded it for days on end. Uh, I seen a video not too long ago of, I don't know where it's at, but every day, same exact time. I mean, I highly doubt it's the 100% exact time, because you can't fucking account for the milliseconds and everything else beyond that. But if something's being recorded at 2:59 with 23 seconds, they're coming back and recording the same sky every day at 2:59:23.
Okay.
Same location, same record, same sky, same portion of the sky being recorded, and it's recording the sun, and they tracked the sun and how the sun moved throughout the year in that space, and it was a fucking elliptical loop that sun made, and it's our sun that they were tracking.
Yeah. Okay. That being said, I totally get that. But I've posed this question to several people. Um, and I've posed it to my brother, and my brother, super smart guy. Uh, he's a math tutor for like a university. He teaches at a private school. You know, so you guys know, or our listeners, so our listeners know, my brother's a very intelligent person, super intelligent, and he sent me a thing that showed me a graph on, because I've posed this question to him, and that is, why do we see the same stars every night throughout the year? It just doesn't make any sense. If you really think about it, it doesn't make any sense. And I can let me pull up, like, I don't know, a fucking paint or Yeah, well, I'll just pull up Art Rage. And we'll add that. You guys can't see this yet. Those that are watching on like YouTube, y'all can't see this yet. And I'll stream it for you guys too.
Well, okay, so what is it?
I'm just drawing an example of what I'm talking about.
Oh, you're just drawing an example?
Yeah.
Okay.
All right. So I'm live on Discord. I'll flip over and
Tell them no, Earth is an octagon.
there it is.
You have to call him the
Okay,
kid.
ma'am.
Good morning.
I haven't been asleep yet.
Okay. All right.
Not what your husband said.
An
The Earth is what?
octagon.
An octagon.
Yeah.
So you heard it.
You heard it here first, folks. The Earth is an octagon. All right. So, we'll go blue. All right. So here's Earth, right? Let's.
I guess, I don't know. I don't see crap.
I see something that looks like a old disc
Let's.
in the right corner.
I'm gonna erase that. I'll make something a little bit bigger. Hang on. All right. Oh. Here's Earth.
Something we do.
It's
Okay.
a
Here's
great
Earth.
school drawing that.
I guess.
Actually, that's way too big. Let's undo that. Here's Earth, right?
Uh-huh.
Ah, blue circle.
Here's the sun.
Uh-huh.
Now, I looked out last night, and I know because I've been paying attention. You see the constellation Orion all year long.
Hmm.
Like you can look out tonight if you're in the like northern hemisphere, and you will see the constellation Orion.
Okay.
Okay. Now let's say this is where we're at. We're right here, and that's yeah. And see, we are facing this direction at night.
Yep.
Okay. Now, when we're over here,
Mm-hmm.
and we are facing this direction, how do we see Orion? Because if Orion is in that direction, we can't see it because of the light from the sun.
Because our orbit and the sun's orbit is not stationary.
Our orbit and the sun's orbit is not stationary. That still doesn't make any fucking sense, man.
We're in a spiral.
Okay. If so we're moving in a spiral pattern. All right. Cool. I'm totally down for that. We are moving in a spiral pattern. That doesn't mean okay. You're in a car, right? Let's say you're
No, he's in a truck with a trailer.
not
attached to it.
at this very second. Was
Yeah,
this-
he is.
Where's the? There it is. All right. I got one for you. All right. You're in a city. Oh, Barry, it doesn't matter. You're on the road. Right here is a roundabout.
Mm-hmm.
And you're driving around the roundabout.
Yep.
Okay.
I'm following you.
You can't see anything over here because of the roundabout.
But
How-
I can.
No. Let's just assume that the roundabout's blocking your vision. Like, say there's
Okay,
something in the
so
middle of it. There's a big
I'm going-
statue
I'm-
in the middle of the fucking
I'm going
roundabout.
around a big statue. The roundabout is basically a big statue that blocks my field of view.
Yes.
Okay.
Okay. So when you
So
look,
how can I see something on the other side whenever I'm on the opposite side of
not
it?
even on the other side. You look out the outside away from the statue.
Okay.
Okay? You look out away from the statue and you see and you still see whatever's over on the opposite side of the statue.
Okay.
Now, how's that possible?
If you're taking it into perspective of how we orbit the sun, because our orbit is not just a perfect circle. It is
It's an elliptical, but it doesn't matter because here let me show you.
It's elliptical. It's also in a spiral pattern, and we are also rotating at the same time.
Yes, but for that to take place, everything would have to be moving at the same speed, and it's not. They know this. Like, that's what science says, is not everything in space is moving at the same speed.
No, everything isn't moving at the same speed, but the speed of light is. Because that is constant. That's how we measure everything.
Okay, but the speed of light doesn't change direction that it comes from.
Correct.
So let me draw a sideways view here. Right? We'll go here. We'll make the sun again. Sun. We'll go here. Make the earth again. Earth. Right? And then we'll do this for Earth's orbit. Earth's orbit kind of goes like this from the sideways view and comes around behind the sun and back up through here. We should not see anything over here when we're on this side of the sun, because from our perspective we move around the sun faster than we go through the spiral.
No, it takes us 360 plus days from one starting point in our orbit to come right back around to the same starting point.
Yeah, no, you're absolutely right. But how long does it take for stars to move? How long is the rotation of the galaxy?
Though that's beyond anything that I know or comprehend, so I can't tell you.
So it takes millions of years for the galaxy to do a full rotation. And in that, let me clear layer again. So we have the galaxy. You know what? We're gonna make it this a little more interesting. All right, and now, okay. That's, oh my God. I'm on the wrong thing. All right, there we go. So our galaxy kind of has this shape
My
to it.
milkshake brings all the boys to the yard, and they're like, it's better than yours.
Appreciate that, Crash.
How
Appreciate
did you do that?
It's a soundboard.
Yeah.
Yeah, a while.
A
You mean a while?
A while.
A while.
In the world?
Yeah. So
Would you leave them alone?
No, it's my job to bug them.
so let's say we are here, right?
Mm-hmm.
Our orbit around the sun happens millions of times, and we are facing in different directions of the star every night of the year. Granted, we don't the observable rotation takes a year to do, and for us that's really slow. But at some point, we should be seeing the center of the galaxy because we face it at night, but we don't. What you're saying is that our rotation and our spiral always keeps us pointed at the same night sky 365 days of the year. And we never move out of the same night sky.
Right, but the same night sky is never in the same position every night.
We should not be seeing the same night sky. That's my point. We shouldn't ever see the same night sky for more than maybe a month. In fact, what my brother sent me, what he found, the answer is that we don't see the same night sky. We just see constellations that look similar to each other. But that doesn't make sense either because the stars' positions don't align so perfectly that you would confuse one constellation for another.
No, I mean, it is a possibility.
I mean, it's like this. Where are you at? Like, where are you at right now? You're
Me?
Yeah, like if you're sitting, right, and you're facing a
Uh-huh.
single direction, it doesn't matter if you're spiraling or not. You can't see the shit behind you, right?
Right.
Okay. So if at night your outward look is looking like that, how are you seeing shit here when you're in fucking midwinter over here?
Best explanation? This is gonna sound fucking weird as shit. I still fucking have thoughts of our world being in a fucking simulation. And that's the reason why our night sky really doesn't ever change.
I mean, the possibility that we are living in a simulation is not so astronomical that it.
So he thinks we're in the Matrix.
I mean, have you seen the videos of like glitches in the Matrix where shit just appears or disappears out of nowhere?
Y'all are confusing the heck out of me.
And
Don't do that. Don't do that to me. I haven't slept yet. Don't do that.
for everyone wondering, that's Mrs. Crash.
Ooh, I'm missing Crash. Woo.
She is Mrs. Crash. This is her first guest shot on the podcast. Welcome to the podcast. Do you have anything you would like to add or a comment you'd like to make?
Other than the fact that we're confusing the fuck out of you.
What?
You kind of cut out.
Would you like to say or comment on anything so far in this episode?
I don't think so, besides the fact that I haven't slept and you're confusing the heck out of me.
Okay. Well, I'm sorry that we're
Thank you.
confusing you. Oh, you're
Hey.
welcome.
It's all good. I'm a blonde. You should know that.
Yeah.
To be fair.
To be fair.
Yeah, to be fair, I am a blonde. We are dumb. Some of us.
Well, the idea
Straight-
I'm posing here is that if our Earth really is a globe, and I'm not saying that it's not, but that if our Earth really is a globe and we rotate around the sun, that every month we should look up at the night sky and see different stars. We should not see the same stars throughout the entire year. And the idea that we do suggests that we are in a fixed position.
We could be in a fixed position.
But that would throw you to admit to.
Oh.
And I understand you're saying that hypothetically we could be, because we don't know, and that's all that we're saying here, ladies and gentlemen, is that we don't know.
He's thinking of something to draw. You can see his.
So we're here, and Orion
She said the Earth could be moved closer to the sun so she can be warm.
she would burn up.
I
As,
didn't say nothing.
No, she wouldn't burn up. The heater still be on.
Okay, that's probably true.
but you see this constellation throughout the year. We should not see this constellation like at winter and summer, because we're in completely opposite positions during those two seasons in relation to the sun. And the movement of the stars is so slow by our perspective, it takes a really long time for anything to change. Like, there's also the example, and they just recently destroyed this, but there's also the example of the Georgia Guidestones. And while they were up, before they were destroyed, one of them had a hole in it, and it always pointed to the star Polaris, which is our North Star. And I think they said every year is like, what do they say? Like an eighth of a degree. And they were up for 40 years. That tiny hole should not have had Polaris dead center for 40 years straight. That star should not be visible through that hole at night. But it is.
No, a lot
Well,
of people are talking about research that they've been doing with that. And their research states that as we're orbiting the sun and our rotation and everything else, the position of the stars are actually moving because they're stationary. And we're not. But the degree in where they appear in the night sky changes at least 4 degrees every night.
Okay. So then you agree that the North Star should not be in the same position and be visible through, like, I think it was like a half-inch hole through a concrete slab over a period of 40 years and not change positions. Because I am saying that should not be a thing. But it was. They've destroyed the Georgia Guidestones at this point, though. So we have no way of knowing for sure anymore what's going down there. We can't just go down there and find out.
No, I mean, that, yes. And there's something else that was brought up. And there's the research for that is the reason why the Big Dipper is always visible is because it's circumpolar. It is the celestial North Pole.
Okay. All right, hang on, because I got you on this one. Not like I got you, but like, hang on, I understand where you're coming from. Let me Let me draw something for you. So we're on an axis, right?
We are tilted on our axis. Yes.
Yeah. You know what? I'm gonna make this chalk. Yeah, that's better. We're on a blackboard now. All right. Here's the sun. Here's the earth. Here is our axis, right?
Mm-hmm.
So we're pointed in this direction. If we are up here, right? If we're up here on this part of the planet,
Yep.
then at night we are facing this way. So when we are on this side of the planet, we have the same tilted axis. We are pointed this way. Our North Star is up that way. But we should not be able to see anything. Our line of vision stops there because of the light of the sun. Let me help the blinds out here. The light of the sun.
She just gave you like a look. You know where to go.
I'm just teasing you. Yeah. I'm just teasing.
Oh, that hurt a little bit. Oh wait, never mind. It's like, oh.
But the light of the sun, because at this point is where twilight is. The light of the sun stops here. You stop seeing because of twilight.
Not that Twilight.
Yeah, not the book.
Not the movie. We wait for the movie.
Oof.
You got her all excited. You said Twilight.
Team Edward, yeah.
Yeah. You know what? That's a whole. You know what? You and I should sit down and watch those movies together. I would totally be cool with recording you reacting to my reaction of this movie.
Yeah, he's talking to you.
Well, you gotta come to me first.
No, just hop in the Discord. We'll watch it.
Discord.
Yeah, we can watch it.
That's what we're on.
Yeah, we can watch it together on Discord.
That's why we switched to the PlayStation when we talk to one another through the game.
Does he scream like a little girl?
No, that's Ken.
He's not even here to defend himself.
Yeah, he does though.
Anyway, so what
That's not his real name.
I'm saying is that we cannot see past this line, because past this line we are looking at the sun. The North Star is
Right.
over in this direction. We can't see it because of the light pollution from the sun.
That is true. We shouldn't be able to see it because of light pollution, but that I don't know anything about that one. That is where you need an astrophysicist to actually explain it to you a lot better.
Well, I don't think we're big enough for Neil deGrasse Tyson to come on here and explain it to
No,
us.
we are not big enough of a podcast to get Neil deGrasse Tyson on our podcast.
I don't
Although
think
I
I'd
would,
be
lo-
able
I
to
would,
say
I would, lo- I would love to fucking pick his brain on that.
Yeah, I would too. And maybe I'm just too dumb to understand. Like I'm not opposed to the possibility that I'm too dumb to understand it, but I don't think that we should be able to see the same night sky all year round. It's like, and for all those listening, and for Crash and Mrs. Crash, and even you, kid, go out tonight and look at the night sky. Just take stock of where the stars are. And then maybe set yourself an alarm or write down on the calendar in like 2 months' time to go out that night and look at the stars. And tell me you can't see the same ones.
I'll have to do that whenever I get home because I'm traveling.
That's fine. The thing
I'll look at them on my way to work.
Because to the 2 months time, there's no guarantee I'm going to be back in the same spot to take a look at it again, and my home would be more.
Here's the thing, I live in
ideal.
I don't live where I used to live. I live over 1,000 miles difference from where I used to live, and I still see the same stars. If you live in the northern hemisphere, which is right here, that's all of America. All of America sees the same stars at night. So you could.
I'll have to do that. I'll have to go out and take a look and see if I can't find the North Star, and do a little bit of picture taking at night to see the location of it and see in 2 months' time if it changes at all.
Because if it doesn't, that proves my point. Like it's one thing for scientists to say, okay, Earth isn't flat, and I understand that because in their model, hang on, I'm going to clear later. In their model, they have Earth as a disk. And then you have the Americas, Greenland, and Europe. And what they're saying is that there's a pinpoint of light that ends around this area. But that doesn't make sense because if you're on a flat plane, light doesn't work that way unless it's not as far away as you think it is. So we'll add just a new layer. We'll make this one invisible. So let's say this is our plane, right? And we live, here. Unless that light is down here, its rays only go so far. So it would have to be a lot closer than what we are. But the moon moves in front of it, so there's no way. Because we see the moon eclipse the sun. Like, that's an observable fact. They can't be an equal distance away from us.
No, I think the moon is like 256,000 miles away from us.
Yeah. Well, I think it's more than that.
Well, I mean, I can look that up real quick. Distance to the moon is 238,900 miles.
Okay. Okay, so it is,
The sun is 92.96 million miles away from us.
Okay. So in the globe version, I'll clear this time. In the globe version, you have us.
Mm-hmm.
Then you have the moon out here. And then if we were to zoom out, we'd have the sun. What? The moon's rotation is... Oh, wait. The moon actually is lower. Moon's down here. But, like, if the moon orbits the way they say it does, it doesn't... I don't think it should. Because the moon's definitely far enough away for all the continents to be able to see it.
Right.
But what they say is that the moon's eclipse travels like this. Like this is like a different hour. So each one of these is like first hour, second hour, third hour, fourth hour, fifth hour, sixth hour, seventh hour. If that's correct, then the moon's elliptical orbit is like that. Almost like it's in line with our... almost like it follows our polar... axis. That's that's what I'm thinking of. Almost like it follows our polar axis. So if our planet is tilted like that, that's a poor drawing, and it follows this axis.
Our axis is actually different than that, but yeah.
Yeah. It's what, like 15 degrees or something?
Well, we're tilted on our axis, so, and everything that they've shown that how our axis is tilted, where it's actually tilted to the left.
Are you saying axis or something else?
The axis.
There you go.
AXIS.
Sounds like you saying ASS.
No, I was not saying asses.
That's what it sounded like.
Y'all got ass on the brain.
We keep talking
Well,
about
you did
Twilight,
ask.
and now she's thinking about Edward's ass. That's what's happened here.
Jacob.
That's Chapel's favorite.
What?
No,
Jacob.
it's... Oh, my God. You know who my actual favorite character of the Twilight series is? It's Bella's dad, because he's the only one that seems to have any kind of sense in that whole fucking movie series. Everyone else has lost the fucking plot. It doesn't make any fucking sense to me. But that's a whole different story. I have so much shit I can talk about Twilight.
All right, go back to your drawing.
All right.
But with all the... I don't know how to explain all this because it comes out better from other people than what it will mean.
Mm-hmm.
It's the whole concept behind flat Earth, and it was a study that was done, I want to say thousands of years ago, in like the ancient Greek times, where they disproved the theory of a flat Earth then because of sunlight in a well and the angle in which the light was inside the well and the shadowing from it. And they dug 3 identical wells. I don't know exactly how far, but I'm going to say about a mile apart from each other. And at the same time, they checked all 3 wells and recorded different angles of shadowing from those wells because of the light. And whenever the sun was directly overhead, they did it again, and yet again, the distance between those wells gave different shadowing on the wall.
How far apart were they? They had to
I
be
want
more than a mile.
I don't know how far exactly. I just said a mile just to be the hell, just to say it.
Because here's the thing. I've seen a lot of the flat Earth stuff, and while before I thought it was stupid, it is not. There's actually a lot of really intelligent arguments that can be made about the flat Earth. I don't believe it that our Earth is flat, but there's a lot of things that people that believe that your globe structure and model is the truth. There's things that they cannot explain, like so. Hang on. I want to make sure I get this right. That's not even the right thing. All right. There it is. So the diameter of the Earth, like if you put a line through it, the diameter of it is only 7,917 miles. And its circumference is only 24, like right at 25,000 miles around. So as you're like looking out over stuff, let's clear this. So as you're looking out over stuff, you see the curvature causes a drop. Like, I think it's 6 feet for every 3 miles. But you don't quite see that. And if you're elevated, that amount disappears. Especially so like if you were to zoom out on something that's maybe, let's say, let's say you're at a point, right? Let's make sure you're at this point here, right? The curvature, as you look out, 3 miles is 6 feet. That's a terrible looking 6 there. So then you have 6, 9, 12, 18. So as things get further out, 12, 18. 24. 30. I'd say 30 feet that's like 3 stories. A lot of people don't realize that 30 feet is like, that's a 3-story building. Well, it's more of a 2-story building because you need the extra, like, couple feet between, like, floors. So something that's shorter than a 2-story building, like a small boat, you should not see it once it's beyond probably 9 miles out. But if you're on a flat plane, you can actually zoom in and see something. But if the Earth is curved, they're here, and you shouldn't be able to see that. Now, what they've said is that it's because of the reflection of the sun, but this argument can be made over land, and they can't explain that because there's no water to refract the image of that boat off of. Now, again, the argument can be made for like if you have like a flat Earth, you go further up, eventually you'll see the edge. And I don't know about you, but I've flown from Atlanta to Seattle, and I didn't see an edge. And
I've been on a cruise. I've never saw an edge.
Yeah. Well,
I saw the curvature of the Earth from the cruise.
Yeah. Well, and the thing is like, they say that our edge is Antarctica. The Antarctica isn't actually a continent. It's more of like a ring of ice. And beyond that ring of ice are other basically worlds, which I think is a fantastic idea for a novel. But beyond the ice is other worlds, and there are recorded things of people who supposedly have gone beyond the ice, were gone for several years. You could not find them, and then they came back. And one dude in particular was like a explorer or researcher. He went beyond Antarctica to one of these other worlds, was there for like 15 to 20 years, and came back with a wife who was not familiar with our world, like at all. That he didn't leave with. He didn't leave with this woman. Like, no one could identify her. I just think there's a lot of information that's being left out of the public view and the public knowledge, and that for us to know it and understand it would cause problems for the people in power. Like so, for those watching, if I'm up here, I can see this. In fact, I can see all of this. I should be able, at some point, if we're on a flat plane, I should be able to go up high enough to see all of the edge. And we just don't have any evidence of that. God, I wish Ziddy was here. Ziddy had a bunch of stuff that he wanted to talk about, but he's passed out right now. We'll have to do a Flat Earth 2, I think.
I'm pretty sure we will. Because, I mean, I wish I could... I need to actually start saving all this shit down even further. But like I said, with that whole light test that they did, thousands of years ago... I think it was like Aristotle and I don't fucking remember his name. The theory comes from his last name, Pythagorean.
The Pythagorean model. I don't know if he and Aristotle actually were alive at the same time.
Well, I don't. Well, I'm pretty sure they weren't, because you've got Aristotle, you've got Pythagorean, and you've got Galileo.
Mm-hmm.
They all had conclusive thoughts, theories, and so on and so forth that they based around each other's work and research. And that's where that whole disproving of flat Earth during their time comes from, because of how light works, and recording angles of light, from light and shadow, those two, and then going, and having the same recordings done at the two other fucking wells, and they're all in a straight line from each other.
Yeah. Let me look into that. Hang on.
And with that, I mean, I don't know what to tell you as far as as the night sky and why we can see specific constellations all year round, other than the fact that we are in the northern hemisphere instead of the southern hemisphere, because I think it's something of, once you get like below the equator of the Earth, the constellations change and you can no longer see the northern constellations.
Well, yeah. So here's the thing: in the southern hemisphere, they go by a different star because that to them there's a North Star there too, or maybe it's the southern
It
star.
might just it might be just how our universe is comprised, and
But-
why we can always see those specific type of constellations, because it's always in our hemisphere.
Okay, I'm just going to say this because I know we have lots of listeners, or well, we don't have lots of listeners, but I'm hoping that one day we'll have lots of listeners. But I just want to make it known that the idea that our universe is set up so that we see the same night sky every night, that so much that we can actually measure our distance and maps and create maps by using the stars and their position in the sky, and that the earth and that the moon is far enough that it is almost the same size of our sun when it's in front of it by our perspective, that we live in the what's called the livable zone, and that we have just this perfect rotation that doesn't cause any like insane issues, and that we have a moon that this just happens to have collided with the earth and created our situation the way it is, suggest intelligent design. It strongly suggests that someone or something set all of this up.
Into the Big Bang Theory and creation.
See, that's the thing. It all happened by chance. All of the perfect scenarios, the astronomical, like the number, the exact number of statistics for all of this to happen by chance, I think is higher than the stars in our galaxy. Like that's how much of an impossibility it is. That the chances of that happening is a number so high, it's more than the number of stars in our galaxy. So yeah.
So I mean that goes. This also leads into another thing that I wanted to talk about. And I mean, it goes into the whole terraforming and so on and so forth, along with the fact that it's like hydrogen, carbon, and I forgot what other chemical. Those three are the most prevalent throughout the entire galaxy. And I think I killed everyone.
No, you didn't kill me. Say that again. I'm sorry. I was trying to figure something out because apparently the. Oh, I know.
Okay.
I did. Okay.
The most common elements in the
Mhm.
universe.
Yes.
The top three are hydrogen, helium, and oxygen.
That's what I wanted.
And carbon. Carbon's in there as well. And actually, the 10 most common are hydrogen, helium, oxygen, carbon, neon, nitrogen, magnesium, silicon, iron, and sulfur. And our atmosphere alone, I know of, is made of at least 5 of the top 10.
There we go. All right. Well, shit. We'll have to do this in the second one. I just figured out how to get the art rage working so that other people, so that anybody watching could actually see it. All right. But yeah. And we just happen to be in one of the most rich places in the galaxy for those elements.
Well, I mean, we are. Mars is as well. They've proven that Mars can sustain life and has possibly sustained life previously, because there's evidence supporting that Mars at one point in time had water on the surface. And they're also stating that underneath a layer of Mars's crust, we'll call that,
Mm-hmm.
there is water still there, frozen.
Yeah, well, I mean, it does have a northern and southern ice cap.
But yet again, like I said, with all that, with the whole flat Earth thing, my whole premise behind it is that it's not possible, because if flat Earth was a real thing and it was possible, flat Earth can't explain in their whole theory behind it solar and lunar eclipses.
Yeah.
I don't remember which one it is. It's either, I think it's the lunar eclipse, where we are passing in front of the sun's light and blocking the reflection of the light off the moon.
Yeah, they can't explain that.
And then I believe it's the solar eclipse or it's something like that. I think it is solar eclipse where the moon passes into the light of the sun,
Hmm.
blocking for us to see briefly.
Yeah, and it's also
I mean,
observable. Like you can they and since the people can actually see it now, they can track it. The last time I looked at it, they had the Earth. It was like this, and then you had the moon, like we'll say here, and then they were tracking the eclipse. They were like here at this hour, here at this hour, here at this hour,
yeah,
here at this hour, and here at this hour.
and it was all a fucking all day event. But in those specific areas of the planet, the solar eclipse only lasted for like a minute or two.
Yeah. The thing is like if you're not in this, like say you're up here, let's say you live up here, you're watching the moon get really close to the sun and not
And
get in its way.
I've seen a total solar eclipse
Yeah.
back in
Yeah, I
I
have
want to
too.
say 2017.
Yeah.
And because I live in South Carolina, and South Carolina was in the path of totality.
Yeah.
And I've witnessed lunar eclipses, which by far is like the coolest thing ever, because the night sky is bright from the reflection and everything else, and then it just goes eerie fucking dark,
Mm-hmm.
and then back to light. That to me is more than enough example and proof that the Earth is not flat. Because if the Earth were flat and we were in spinning rotation, it's like taking a fucking quarter and flipping it in the air.
Yeah. Well, the thing is
At one point in time, you'll see all of the Earth, and then you won't, and then you'll see it again, then you won't, then you'll see it again, then you won't.
Yeah. Well, the thing is like so. Hang on. So what they believe is that we are a plane. We have a layer of ice that goes around us and keeps us in place. Well, almost like we're a large lake. Which is funny.
A large
because
frozen lake with a landmass in the middle of it.
with a bunch of land masses in the middle of it. But here's the thing. If so let me get through this. The idea is that we are not spinning, we are stationary. And that we, because of like say the sun, that's too much screen.
So basically, that whole theory of us being stationary and flat Earth, it goes right back into the whole thing of we're the center of the fucking universe, and the sun and moon rotate around us instead of us rotating around it.
Yes. That eventually is what it becomes.
And that is completely asinine and retarded.
So the idea is that the sun and moon rotate in the same direction. The problem with this model is that we can look out into the night sky and see other planets. Like you can
No,
get
not
into
just that, but the whole thing of the sun and moon are in orbit around us would mean that the sun would always rise in the same location. If I'm standing magnetically due east, every morning at sunrise, I should be hit right in the face
Mm-hmm.
by the sun coming up.
Yep.
And but at by midday, if I fucking turn due west, I should be hit in the face by the sunlight by the time it starts going down.
Yeah.
But it's never that way. The sun, I mean, I just seen the sun not too long ago, and the sun was just barely off to my left shoulder.
Yeah.
And I was traveling east.
This has been riveting, but I'm
The
going to crash.
The two of you are going to, Mr. and Mrs. Crash are going to go crash?
Yes.
Okay. Well, you guys have a wonderful day and sleep well.
All right. We'll see you.
We'll see you.
And that's one reason why I can't get behind the whole flat earth thing. Because for that to be accurate, why the hell does the sun never come up directly due east and never go down directly due west?
Right.
I mean, there are some points in our calendar year where that does actually happen. But for the remainder of our calendar year, it is never 100% east and west.
Right.
It is always slightly off by some degree in either direction. Like sometimes it'll come up slightly southwest or southeast and go the opposite direction. There are times where it'll come slightly northeast and go in the opposite direction.
Mm-hmm.
And
the
that,
thing is,
to me, is also with, you talk about light pollution and, everything else, and we shouldn't be able to see things. I have, and people have told me that I'm wrong about this, and sorry, I've got to get this out. I have seen, as the sun is coming up in the daytime,
mm-hmm.
the moon's fucking reflection still there.
Yeah.
Why?
Yeah, and the thing is supposedly their orbits are not aligned. They just line up sometimes, but they're not. For the flat Earth version, the orbits themselves are elliptical, and they don't. And sometimes they line up and block each other off. But the idea is that they go in this direction, and this is north, and south is over here. The problem is that when you get to say the problem with the flat earth is the same. It's actually the same problem that the globalists have. It's the night sky. If you're on Earth and it's flat, when you're here, and here, your nighttime are three separate directions, right? But all three of them see the same grouping of stars. Because this right here is our hemisphere line. Anything on this side is in the north, and everything on this side is in the south. The southern hemisphere and the northern hemisphere should be sharing the same stars, depending on the direction.
But they don't. That's another problem with this.
Yes, they don't. And that's also the problem with the global thing, because we see the same stars in the night sky throughout the entire year. If we're rotating around the sun at the speed that we're supposed to, we would not see the same stars in the sky. Not throughout the entire year. We'd see them for about a month, and then they would slowly move out of our vision, and we would see a new set of stars coming in. You should not see the same constellation in the sky 365 days out of the year. but you do. If you pay attention and you look up at the sky, you do.
No, I mean, with that too, it goes into how much of space have we truly seen?
Nothing. We have
And if you were to compare it to the Earth's ocean, that's like going to the ocean and grabbing a glass of water,
yeah,
looking for fish,
and going
and
there's
not
nothing
finding
there.
any fish, and
Yeah.
there's nothing there.
Yeah.
So the amount of our, they talk about, we haven't explored and discovered most of the Earth's ocean. They're correct, and we haven't even the amount of ocean that we have discovered isn't even on the same scale of the amount of space that we have discovered and seen.
Yeah. And you know what's
Like,
and the thing
like
is
that
like,
that is like the tip of your fucking fingernail compared to your hand.
yeah. And the thing is like, there's some really weird stuff about the flat Earth thing that they don't want to talk about. All I'm saying in this episode, as far as what I believe, is all I'm saying is that I don't think either one's right. I think there's a lot of information that we don't have that's being kept from us. I think that I don't trust any of the government to be honest with me and just give me the knowledge, give me the facts as they should be presented. And I mean just the facts, ma'am. I don't need none of your fluff. I don't need none of your garbage. You just tell me what the facts are, and I don't need no opinions or biases.
I agree with you on that one.
And if I don't,
I'm not going to say there's conclusive evidence that puts Earth, because I know it's not a perfect sphere. There's no way in hell that we are living on a perfect round sphere. We are living on a elliptic sphere, because even famous astrophysicist Neil deGrasse Tyson stated that the equator, if you're looking at the globe itself, the equator is longer than the rest of the circle, even if you cut it in perfect sizes. North, south, east, west, the equator is longer. So it is not perfectly round.
doesn't that go against his own argument of if like some cosmic entity reached out and grabbed the Earth, it would be smoother than a cue ball? Well, no, it doesn't. But
Not really. It doesn't go against that.
okay, no, it wouldn't. You're right. It wouldn't go against that. It would. It would, however, suggest that the composites we've seen do not perfectly fit what's out there. And it's weird because when TikTok was first getting big, I remember seeing like live video footage of astronauts like up in the atmosphere making recordings. Did you ever see that?
No, but I mean, that also goes into something else that Mr. Tyson has stated, that if you take one of our globes and you want to put it into scale on how far out the International Space Station is, it's barely out of our atmosphere.
Right.
Like, barely out of our atmosphere. It's not even in what they would consider space. It is still within the Earth's atmosphere.
here's the thing, though. If that's true, they're still high enough that they should be able to A, either see the edge if we're on a flat plane, or B, see the curvature of the planet.
Oh, they see the curvature. Even the guy that fucking did the what was that? The fucking I want to call it the fucking halo jump. The guy who went up so far in, in our atmosphere and came back down, even he stated he saw the curvature of the earth from that fucking far up.
Yeah. Okay. We're actually over time.
Oh yeah, I'm pretty sure this episode went way the fuck over time.
Yeah.
We are definitely gonna have to pick this up for another episode.
Yeah. So,
and
if-
hopefully when we pick this up, we will have more of our podcast crew available.
Yeah, definitely. Well, this has been a lot of fun. This episode was a lot of fun. I'm glad we're getting back into some of the science stuff.
Dude, I'm fine with doing science stuff. I've told you this countless times.
Yeah.
There's more science stuff that I want to touch on.
Yeah, I do too. I want to do another.
you and I wanted to do the whole Terrence Howard shit.
Yeah.
I want to touch on that. I want to touch on a lot of other things that deal with our Earth, like I've mentioned in this episode. Maybe we are living in a simulation.
Yeah. Well, the thing is, and it used to be on YouTube. There used to be a documentary on YouTube. It's old, and I mean, like, this would be like something that's like 10 years old or more. A video documentary I saw on YouTube. And the idea is that I don't think it's available anymore. I think YouTube took it down or something. But you have the scientists on this documentary. Don't know why I'm so out of it today, but they were like, they say that they were trying to use the idea of the multiverse to disprove God, or to show proof that God doesn't exist. And they said the more they tried, the more evidence they had of intelligent creation of our universe. And I thought that was fascinating. I sent it to an atheist, but I don't remember if that video is available anymore. I'll have to try to find it. And if I can, I'll put a link up. So
I'm not saying that, I'm an atheist by any means.
Mm-hmm.
But I'm also, you know me. Our listeners don't know me that well. I was raised in a certain type of Christianity household.
Mm-hmm.
I do not throughout history and everything else, everything about it, I cannot sit there. And this is something that a well-known atheist talked about.
Mm-hmm.
I can't sit there and believe in just one solitary being and deny all the others ever existing. If we were created by some omnipotent source being, whatever, religion has warped and twisted that view so far beyond repair.
Well, I mean, that's a whole nother episode, man. We, because the thing is like, so I try, because I am a Christian, I try to approach people with an idea of, or with an attitude of open-mindedness and understanding, and being willing to listen to people, and understanding that, you know, the life that they have lived is different than my own. Their experience in their life is different than my own. However, that does not mean that they get to violate the rules or that the rules don't apply to them. The rules apply to everybody. Now, that being said, I try very hard to not approach an atheist with the way that most atheists have approached Christians in my experience, which is very condescending, very, you know, I'm smarter than you. Because I could have that attitude of yeah, you don't know what you're talking about.
And that would be well within your right to do so.
Yes, but I'm not supposed to, because I'm supposed to follow
Right.
the rules, and you're not going to get a man to drink from your cup if you fill it with vinegar.
Very true.
So, yeah, this is one of the longest episodes we've ever had. So we're going to end it here.
Hey, we're definitely gonna have to pick all this back up at another time, because we just unpacked so much more.
Yeah. I did not expect this episode to go this long. This was fantastic. I loved it. We're definitely doing this again. All right. Well, to everyone listening, thank you so much. Please like, comment, subscribe, and you all have a wonderful day.
And remember, today's episode was brought to you by Equal Opportunity Insurance. For your privacy is our policy. If you don't think that we can't cover you, we have a policy that for every amount of privacy that you need.
All right. Y'all have a good one.